All right. So here we are for Honors Physics Projectiles Worksheet 2. I'm going to do problem 2. So problem 2 says a baseball is hit with an initial horizontal velocity of 14 meters per second and an initial vertical velocity of 14 meters per second upward. What are these velocities 2 seconds later? So let's see here. I know I'm going to have a baseball bat. Okay, again, I'm always going to start with a sketch because that's the way I am. All right, and we're going to be hitting that baseball such that that baseball has this initial horizontal velocity of 14, initial vertical of 14. So it's horizontal velocity, 14 meters per second, and its vertical velocity, 14 meters per second. We recognize that if you have equal horizontal and verticals, we know that that means you're going at a 45-degree angle. The total velocity goes like that. So the question is, what are these velocities going to be 2 seconds later? Well, you know a couple things that we know about all projectile problems. For all projectile problems, we know that in the horizontal axis, the acceleration is 0. And that means the velocity is constant. So 2 seconds later, if it started off going 14 meters per second sideways, 2 seconds later, it'll still be going 14 meters per second. So we know that v, I'll put a subscript x, the horizontal velocity is still 14 meters per second 2 seconds later. Not the case for the vertical velocity, on the other hand, though. If I think about the vertical axis, we know that the gravitational force is pulling downward on the ball in that axis. So that's going to change its velocity. So if I did my y-axis, I'd be like a, v naught, v, displacement, and time. Dunk, 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 dunk. And you say, hey, I know in the vertical axis my acceleration is negative g, which would be a negative 9.8 meters per second squared, assuming, of course, that we are calling up and right positive. So the acceleration is downward. That's the way the force of gravity pulls on the ball, and that's the way the acceleration would be for the ball. The initial vertical speed we know is 14 meters per second. It's going 14 meters per second right and up. We want to know what's the velocity going to be. So question mark under v. And we don't know anything about how high it goes, but we do know 2 seconds later is the time. So we've got a, v naught, v, and t. We want the formula that doesn't have delta y. That would be this one. V squared is v naught squared plus 2a delta y, right? No, I want the one that doesn't have delta y. What am I saying? What am I saying? What am I saying? It's the easiest one too. V is at plus v naught. How silly of me. And I want to find that final velocity. Hey, look, it's already rearranged for me even. It's just going to be an acceleration of negative 9.8 times the time of 2 seconds plus my initial velocity of 14. Substitute that in, and we will see that our velocity will be negative 19.6 plus 14. That would be a negative 5.6 meters per second. That is my vertical velocity component 2 seconds later. So 2 seconds later, we got a negative. You know what that means? That means it's on its way down 2 seconds later. All right? That's problem number 2.